Okay, happy Friday, everyone. One of the last few sessions, so thank you for choosing us. This is a session about OpenTelemetry, and specifically, we're going to talk about how Google Cloud can help you simplify your OTel management. At the end of the session, we expect that you can walk away with two things. One, a clear understanding of the kind of client-side complexity that you will run into when you deploy and manage OTel at scale, and also how Google Cloud can help you simplify those challenges. Before we dive in, let's do a quick intro. My name is Keith. I'm a product manager from the Cloud Observability team. So I started working with OTel about 5 years ago. I was in a software company building their internal telemetry pipelines supporting the SaaS applications. Now fast forward, I'm at Google Cloud working on similar systems, but at a much larger scale, serving a broader range of customers. So I've seen challenges of working with OTel from both perspectives. As the end customer, just like yourself, right, working on their own telemetry pipeline, and now from a platform perspective as well. So I'm very excited to share with you my learnings in the next 30 to 35 minutes. And before that, let me pass to Philip to also give us a quick intro.
Thank you, Keith. Hello, everyone. Nice to see you all here today. My name is Philip. I'm an engineering manager in the Cloud Observability Group based in Google Pittsburgh, where I run teams that are responsible for the ingestion and routing of all customer-facing telemetry across Google Cloud. I have been in the observability space for about 15 years. Before Google, I was part of InfluxDB, where I was part of the team that shipped the first release of that time series database. So looking forward to sharing with you today what we've learned and what we're offering. Keith.
All right, thank you, Philip. So this is the plan for today. We'll start with a quick overview of the current state for OTel. And after that, I'll pass to Philip to talk about, from an engineering perspective, what are some of the client-side complexity that you will likely run into when you deploy and manage OTel at scale. And after that, we want to share with you our vision of using a unified management plane to help you simplify those client-side complexities. And we are also going to highlight some of the features that are readily available today that you can start using for your simplification journey. And after that, Philip will give us a live demo, and then we'll wrap by showing you the next step of how to get started. Okay, so for current state, I want to start with a quick history lesson. So here I pulled some data from Google Trend. It shows you the search interest of the top 3 open standards between the year of 2015 and 2020. Let's try to make this a little interactive. Anyone want to make a guess out of these 3 open standards? Which one is the red line? Just yell it out. One of the 3 options.
Census.
Well, it's actually open tracing. How about the blue line? And that's our spotlight today, OpenTelemetry. So if you just look at the time range between 2015 and 2020, it's probably not entirely obvious to you that which one will become the leader in the open standard space. But if we fast forward to 2025, I think the answer is super obvious, right? Of course, this is just one data point on search interest, but I think this is interesting enough for us to take a step back and think about why that's the case. So we came up with 3 reasons for you. First, OTel is doing a great job in giving us a standard set of APIs and conventions. So for large companies and enterprise, this kind of consistency is very powerful. It lowers the barrier for adoption, it makes it easier for your teams to get started, and more importantly, it allows teams in your organization to speak the same open standard language across the board. So when I was at that software company building the internal telemetry pipeline, one of the things we wanted to achieve is that we want to make sure all application teams, about 15, 20 of them, can speak the same language when it comes to instrumentation, collection, processing, as well as ingestion. And OTel was able to check all those boxes. Now at GCP, we are supporting customers sometimes with over 100 application teams that they need to manage. And this is kind of the benefit that they will get when they onboard to OTel. And also, I want to mention that this standard is also expanded to cover the semantic convention for the agentic AI workload today, right? These are able to show you things like the agent's prompt, the tool calls, and the reasoning loops as well. So this is truly AI proof when we look forward. And the second reason is about interoperability. So OTel is doing a great job and giving us an open standard that's widely adopted across vendors. And at Google Cloud, we are a strong believer in that. In fact, we are deeply committed to give you an open platform using open standards so that you can leverage our infrastructure to do the hard work, but at the same time, own your data end to end. And the last piece is about ecosystem. So OTel has an ecosystem that is still increasing pretty quickly. So there are a lot of players in this ecosystem. There are vendors, open source contributors, the broader community, and many of them are leaders in the AI space. So they are working on capabilities like different instrumentation, collection, as well as backend integration, so that you can land the data to the right place. So this is something that makes the ecosystem more powerful. But this is also where we need to be careful, because ecosystem comes with choice, and choice comes with complexity. So when you need to operate OTel at scale, now you have to reason with a lot more things, like different collectors, different agents, different distribution, right? And a lot more vendor-specific components. Your team now have to spend time to evaluate all these options and deploy and manage a combination of them across your fleet. And this is where the challenge emerges. So choice can be a double-edged sword, right? It can lead to a lot of manual work, in this case, to keep your system up and running. So for those who are already working with OpenTelemetry, you are probably familiar with the OTel collector, right? It's a powerhouse. A lot of choices go into it, right? You have different receivers for your different types of data, different processors you can configure so that you can do things like redaction, transformation, and also different exporters so that you can land the data in the right place. And every bit of that power and choice would actually add to your complexity. Now you have to think about things like managing configuration, resource usage, versioning every single node, et cetera. And you have to do that across your entire fleet. So at scale, this kind of work will add a lot of burden or hidden tax that you have to take on when you run OTel. So to understand the specific engineering challenge, let me pass to Philip to tell us more about it.
Thank you, Keith. So what I want to talk a little bit about today is you may have direct experience of this yourself, or I'd like to help you develop an intuitive sense for what the engineering teams that you manage are responsible for will actually feel or are feeling already when they start running collectors at scale. And that will help you then understand why the system that Keith and I are building and is now available will reduce the burden on your team. The first thing is the OpenTelemetry collector has done a great job of explicitly decoupling instrumentation, collection, routing, and storage. It has really been a great breakthrough to do that in a consistent manner. But it still means that if you are running collectors at the edge, usually often at large scale, hundreds, perhaps even thousands, your edge is still vendor aware. That means you need to have vendor-specific code running in your collector. It means you've got to configure that vendor-specific code. You have to keep up with patches. The vendor issues a new update, you've got to download it, manage that versioning, worry about security, and so forth. The larger your software footprint at the edge, the more complex the risk goes up. The second thing in practice is there's another dimension. Most of us are often running or use more than one observability storage system. You use one for logs, another for metrics, a third for traces. Perhaps you're evaluating one, so now you've got two observability vendors at the edge. The point is that even though the collectors has done a great job, it doesn't absolve you from the responsibility of managing vendors at the edge. The second is a second order effect. Resource consumption, this vendor-specific code, including the code that Google produces, has to do translations. It has to translate from the OpenTelemetry data model that is gathered by the SDKs, gathered by the the OpenTelemetry collector, and convert that into their own data models, perhaps their own protocols talking to the back end. This results in resource consumption. I'll talk more about that, high CPU load, RAM usage, and so forth. The second issue is, and it's orthogonal. Taking a step back, 15 years ago when we had observability, it was really two things: collection, storage, and analysis. That was it. It's in the last 10 years that the routing of telemetry, where certain telemetry should go into certain places, has become an important discipline all by itself. It is the core discipline that my teams at Google actually focus on. But this means that in a large scale, particularly in a large scale collector deployment, you are managing sophisticated routing logic at the edge. But it's probably not uniform. Certain banks of your production system have to do one type of routing. They have to send audit logs in one place. There's another type of logs that are lower volume. You're sending them somewhere else. So there is routing configuration information being stored at the edge. It's a burden on your teams. They have to understand where to go to view this routing logic, maybe somewhere else to view a different type of routing logic, and manage that mapping sometimes inside their mind. And again, the second thing, particularly at scale, is you need to change that routing logic. A new telemetry signal comes on board, a new storage system. The finance team wants a certain type of log routed to a new SOX compliance system. You have to make a change to that telemetry, that routing configuration. You have to push it out. Maybe it's disruptive. It restarts part of your collection infrastructure. What if there is an issue in the configuration? All of these things are practical problems that start to emerge and become practical challenges when you're managing hundreds and sometimes thousands of OpenTelemetry collectors. The last step is all of this taken together. We've all been here. Something starts off as simple. Within a few months or a year, you're starting to look to hire new staff, all to manage what has become a distributed DIY stream processing pipeline on the edge running on your systems. And because this is a complex system in of itself, you need visibility into that. How much resources is it consuming? Why is it so expensive? The finance team comes to you, and so why are we spending so much money on all these resources? And you go and discover that it's actually your own telemetry collection infrastructure that is consuming resources. This is a real problem. It's important. It has to be solved. We cannot run modern computing systems without this visibility, but it becomes a large problem that you have to solve yourself. So let me hand it. So before I go on, let me explain what Keith and I believe is the ideal solution that will address these problems. So now that you've understand the challenge that will emerge, or maybe you're experiencing it already, let me explain what the ideal solution is. What we're offering, what we believe will reduce the burden substantially on your team, is a managed solution. All that configuration, all that routing, push it to the center where you can manage it, audit it, and have visibility on it. By having a native OTLP ingestion endpoint, you remove substantial amounts of code from the edge. No more vendor-specific code. But the key thing, it's not just the managed solution, it's standardized. The data models that at the edge, the protocols at the edge that will be talking to the unified management plane are open standards. If a new collector appears tomorrow, perhaps written in a new language, and it's more efficient, drop it into your deployment. It will more or less just work. You want to decide that you decide to take your collection infrastructure, your collection streams, point them somewhere else, just point them. One configuration, change the endpoint. You don't have to go in and put in, rip out Google custom code and put in vendor-specific code. It's all offered by this. The second thing is the unified management plane is a place where we can do the redaction, routing, dropping, filtering in a central place where, again, you can audit it, manage it, reduce risks so you know what is going on with the telemetry that you are receiving. And again, because it's all built with OpenTelemetry at its center, the interop is there. You don't have to take our word for it. The standards are open, and it is what the new system is talking, and it's what the new system expects to receive. So let me hand it over to Keith to explain a little bit more about what the solution is.
All right. Thank you, Philip. So Philip, help us level set on the kind of client-side challenges that you will likely run into, and also give us an overview of the managed and standardized model. Next, let's look at the solution. I want to first get you oriented with this diagram here. On the left-hand side, you have different environments, right? This is where your workload lives and sends telemetry. So start with GCP, you have different runtime you can use. GCE, GKE, Cloud Run, and also you might have agents deployed in our agent platform, right? They all send out telemetry. And besides GCP, you might have workloads and agents sitting in other environments, like other hyperscaler, public cloud, or your own on-prem data center. That's one end of the story. Now on the other end, you have your backends. This is where your telemetry is being stored and analyzed. Now to connect the two sides, just like Philip mentioned, a lot of high-toil client-side configurations that you have to worry about. And you have to do this across the entire fleet. And this is the kind of complexity we want to help you move away from. So we do that by introducing a unified management plane. And this is a server-side capabilities that's fully managed, and we call it the Unified Telemetry Router. And this solution consists of three fundamental shifts. First is one single endpoint for all your ingestions. So for all your telemetry type, log, trace, metrics, it's one single endpoint that you can send them into. And this endpoint supports OpenTelemetry Protocol, or OTLP, natively. So no more vendor-specific exporters on your client side. This can help you simplify your client-side configuration. And then we want to help you move the heavy lifting from your client side to server side. So heavy lifting are things like filtering, sampling, transformation, aggregation, etc. And once the data gets into GCP, you are using our infrastructure, our scale, to do this hard work, right? No longer on the CPU and memories that's sitting in your client-side environment. So we want you to just provide us the configuration, and then we do the execution for you on the server side. And lastly, after data is processed and optimized, we want you to decide where it goes. By default, it's being routed to Cloud Observability's tools. This is where you can get the first-party integrated observability experience. But if you want, you can export all the data to a third-party destination, or maybe a subset of it to a specific backend for a special use case. And all those are supported. If you remember TK's keynotes back on Wednesday, where he highlighted a couple of things, agent platform and agent observability, and the infrastructure you're looking at is exactly the plumbing that's powering the agent observability experience. So the key takeaway here is that we want to give you a solution that you can use the GCP infrastructure, but at the same time, truly own your data with the freedom of OTel to send it anywhere you want. So that was the blueprint, and next, let's talk about features. So I'm very excited to tell you that today, Google Cloud has a fully unified native OTLP ingestion path for all three pillars of telemetry, log, trace, and metrics. And this is more than just a new endpoint. This is a solution that can help you reduce your client-side complexity, right? Reduce that hidden tags we just talked about. Because you no longer need to mix and match different vendor-specific exporters on the client side. Just use the out-of-the-box OTel collector, or in fact, any agents that supports OpenTelemetry can be used to collect data on the client side. And then just send all your data to one single destination. And this is also more than just sending us your data, right? This is part of the future-proof pipeline that you can use the Google Grayscale for doing the hard work, and at the same time, keeping full ownership of your data. And next, let's talk about some of the specific benefits for each of the telemetry type. For trace, ingestion has been GA since last year. So as part of this launch, we were able to significantly increase the size limit. So if you're running any Gen AI workloads, you know that they generate large size spans, large size trace, and this is the high throughput engine you've been waiting for, so that you can send even richer context as part of your telemetry to your backend systems. And next, we have metrics. Metrics have been launched to public preview earlier this year. A few features I want to highlight. First is exponential histogram. With that, you no longer need to guess the bucket width. You could just send us the data, and we can scale that dynamically for you. And this is also supporting delta metrics already, right? With that, you are able to flush memory between the exports. This reduces your CPU and memory footprint. It's good for performance as well as for your wallet. And with this launch, you can also send metrics directly from SDK to this ingestion endpoint, further streamlining your client-side complexity and footprint. So now all signals, log, trace, metrics follow an open standard ingestion path. Make it easy for you to manage on the client side, and they're already correlated for you so that it's optimized for your downstream analysis. So this is the ingestion side of the story, which is the foundation of this unified management solution. And we have a couple more things we want to share with you. So I want to highlight that for the remaining features, they're still work in progress. But I want to give you a preview so that you know the direction that we are headed. So for server-side processing, the goal here is that we want to help you move the heavy lifting from the client side to the server side. So instead of you having to manage all your processors for every single node to do things like parsing, PI redaction, you just provide us the rules, just like how it's shown in this screen recording. Once we have the rules, we handle the execution for you on the server side. So as a result, you're able to keep your edge super streamlined while still getting the precisely formatted data that's optimized for your analysis. And finally, we have export and streaming, right? That's the egress side of the story. So this is the last piece of the puzzle for us to complete the OTel in, OTel out path. So after your data is being processed on the server side, we want to give you the freedom to send it anywhere you want. Of course, we would like you to keep them in the GCP ecosystem so that you can use that integrated observability experience. But if you want, you can send them to any third-party destination that's supporting OTel. So features in these categories will become available as we enter the second half of this year. So just few more months to go. So I would say stay tuned for updates for the public preview. So I think that's enough talking about the features. So next, let me pass to Philip to show them to you.
Thank you, Keith. So I'm going to drill down just for a couple of minutes, a very short demo to try and again to help people, if you haven't the practical experience, to give you an intuitive sense for how complexity is reduced at the edge. And again, by moving to the managed system, but standardized data models, Keith and I believe that this reduces your costs, reduces complexity, makes developers' jobs and operators' jobs easier, but because it remains open standard, there is no lock-in. You can always take the work that you're going to do here and point it at any other OpenTelemetry collection system. It could be another collector. So this is what we are showing here today. So let's take a look at a classic pre-unified management plane deployment system targeting both third-party vendors and GCP. I have a little demo. It's a very simple app that's a product catalog. You can list products, you can get them, and so forth. Very, very standard stuff. It's instrumented with the OpenTelemetry SDK. That in turn is configured to send telemetry to a local collector that is running as a sidecar. Very common pattern. The difference today is, what happens today is you have to go into that OpenTelemetry collector and you've got to import a bunch of exporters. This is code. It's not configuration, it's actual code that is brought down from open source repos and you have to run it. In this example here, if you want to have your OpenTelemetry collector send data to the Cloud Observability Suite, logs, metrics, and traces, you must add the exporter. It's open source, but still you've got to configure it. Perhaps there are third-party vendors that you also want to send some of your telemetry to. In turn, unless they support OpenTelemetry natively, you'll have to have exporters running here. And this is what it looks like. This is complexity at the edge. Maybe it's not huge when you've got one. It's manageable at 10. But what when you've got 100? Some running in Europe, some running in the US. The development and operations team is trying to manage all of this complexity. It starts to grow. Now, let's look at how this architecture changes when it's pointing at our system that has unified open standards, OpenTelemetry ingestion. This is what it becomes. Of course, there's a small amount of configuration still at the edge where your authentication is inserted, but this is done using standard approaches. It's nothing special here. The application remains the same. The application is instrumented with OpenTelemetry code, the SDKs. Nowhere will you find any Google code. Same in the OpenTelemetry collector. Apart from the configuration option to add something to the header of the HTTP or gRPC request, there's no Google custom code here. There's no vendor-specific code. You could drop in another OpenTelemetry collector that's written in Rust tomorrow, which has amazing performance, and it should still work. Our internal testing has shown that OpenTelemetry collectors without these custom exporters, particularly the Google exporter, showed almost 80% reduction in CPU. That scaled across thousands of units is a big deal. Why? Where is that CPU? What is it not doing anymore? It's not translating from OpenTelemetry data models to custom data models. That data then goes into the system that we have announced, native OTLP ingestion, and then you can have the filtering, the transform, the aggregate, all the functionality that used to exist in the OpenTelemetry collector. And you can set up your routing rules, as Keith mentioned. Perhaps there is another observability system that you are used to using that is your preferred option. It will stream OTLP to that system. So we don't want to be, you're not locked in. The data can stream in OTLP and it streams out. Now, if you could jump, please, to the other connection. I can show a quick demo. Oh, yes, here we are. So I want to show a brief demo. It is not particularly complicated. It is standard stuff. The message I want you to take away is this is done with no custom code at the edge. It's just pure, it's all open source, standards based. First thing I'm going to show you something very simple. The configuration. So for those of you out there who've seen YAML files, here comes one. This is the YAML file for the old, and I'm going to highlight a specific thing, for the old configuration, where the exporters are baked in, tightly coupled to the collector at the edge. You have things like a Google Managed Prometheus exporter for sending metrics, consume CPU. You've got a Google Cloud exporter for logs, for traces, and it goes on. There's various configurations specific. I'm using obviously GCP as the vendor, but this could be any vendor who doesn't have this native OTLP ingestion available by their service. They will have to give you an exporter. This is what the old way looks like. Let's take a look at the new configuration. Exactly same Google built OpenTelemetry collector. But if we look at the configuration, it's all open source. Traces, metrics, all standard stuff that is brought down from open source. This configuration will work anywhere with any OpenTelemetry collector. The only little bit of difference is the authentication flag, so that the OpenTelemetry collector knows how to insert a header that is your API, is your key for accessing the API. So this is a simpler YAML file. It is one you are not going to have to re-engineer when a new version of the OpenTelemetry, when the Google-built OpenTelemetry collector arrives. You don't have to update it. You don't have to manage the custom exporters at the edge. If we take a brief look, this is because the telemetry takes a few minutes to generate. If we take a look at what the telemetry looks like now in our product, I'll just walk you through correlation from metrics to traces to logs. The key thing to understand is none of this requires custom code at the edge. All the investment you do in your OpenTelemetry-based infrastructure will just work now without any custom exporters. Here, for example, is a histogram showing query response times to this very simple application. This is a normal, reasonably good time here. If we show the trace, and what we see is the trace at the very bottom, simple stuff. The query, the database fetch time, very short, everything is fine. But let's say you get reports from the field, the report that we all don't like to hear. My responses are slow. We go into our tools, we find one here, we click on it, we can look at the sample trace. Up it comes. And this shows, the reason this response is slow is the database is slow. Let's drill on the trace. We bring up the logs. Here are all the attributes that came in with the span. We can look at the logs. It says it's a slow query. We already knew that, but we can jump to the logs. At each point, it's all automatically tied together. We can expand the log, and let me show you something that's inside. Expand. Rich telemetry showing everything about this database instance, the region it's running in, the VM it's running in, details about the requests, the machine type. This is a straightforward operational use case. We've all done this all the time. The important thing to take away from this is there's no custom code at the edge. It's all standards-based, point at the native OTLP ingestion, and you will get this nice correlation to help you debug and respond to problems in your systems much faster, with much less burden on your infrastructure and on your teams. And I think that is it. We can switch back to the main slides, please. Okay. All right, Keith.
All right, thank you, Philip, for showing us how we can use the unified ingestion endpoint to simplify the client-side complexity. And next, let me show you how you can get started. Now, on the collection side of things, I want to highlight a product that's already in GA. This is the Google-built OTel collector. The first thing I want to highlight is that this is not a fork of the OTel collector. After talking about 30 minutes on open standard, open platform, I'm not going to show you another vendor-specific component, right? So again, this is not a fork. This is built with upstream OSS, meaning you're going to have the same level of interoperability as a standard OTel collector. But it comes with a couple additional benefits. One, this is optimized for GCP infrastructure, meaning it will simplify your onboarding. And also, this is being provided to you via a secure supply chain so that you can check that security and compliance box as well. So if you're in the market looking for evaluating different collectors and you need to send OTLP signal to Google, I would say this should be a go-to choice. So take a picture of the QR code. It will lead you to the public doc where you can learn more and get started. And then we have on the ingestion side, we have the key feature for today. That's our unified telemetry endpoint. So whether you are thinking about onboarding to OpenTelemetry, want to send OTLP data to Google Cloud, or you're already sending them to the O endpoint, this is something you should consider onboarding or migrating to. So for example, if you're sending us OTLP logs to the logging endpoint, moving to this, we'll get two benefits right away. One, you are going to simplify your client-side configuration because you no longer need to deal with the Google-specific exporter, just like Philip showed us. And secondly, because we moved the mapping from the client side to the server side for you as part of this move. You no longer need to use your own resources, CPU, memory, to do the mapping. So again, take a picture of this so you can see the public doc and learn more about it. And then for the processing and streaming features, like I said, there's still work in progress. So we suggest that you follow our Google Cloud blog. Stay tuned for the updates. Again, we expect that we will share a lot more as we enter the second half of this year. So we are getting to the end of our session. So we would like to help you recap and give you a few takeaways. The first one is super obvious, right? OTel is the industry standard now. We have seen enough evidence out there to kind of make us believe this is the point. And we see a few reasons for that, right? Standardization, interoperability, as well as the ecosystem. And more importantly, it's the ecosystem that's already supporting the key AI use cases today. We will also talk about OTel is a great toolbox, but not necessarily an out-of-the-box solution. Yeah, you have to piece together different things. And specifically for the purpose of this talk, we talk about some of the client-side complexity that you will run into when you manage OTel at scale. And finally, this is where Google Cloud comes in. We want to give you a unified management solution where you can use to simplify those client-side complexities. It starts with a unified ingestion endpoint so that you can simplify your client-side configuration. And then by the time we provide you that server-side processing capabilities, you can further reduce the footprint of CPU and memory on your client side. And finally, once we have the OTLP streaming, that's when you truly own your data and have the freedom to send it anywhere you want. All right, so that's the end of our session. Your feedback is always greatly appreciated. If there's any thoughts, ideas, comments, please fire up your next app on your phone and share them with us. Thank you for attending the session.
Thank you.